Okay, so here's the video to go over mini quiz number 1. Most of you took it, some of you missed it. The important thing, guys, is these videos are going to be there in Google Classroom for you to study in the future. And I need you to be honest. Each of these questions, did you get it right legitimately, or did you have to guess? Did you get lucky on making your guess, whatever? The important thing is I want to make sure you know the thinking behind each of these, because they're not going to give you this exact question, but a very similar question. It's very much a reasoning kind of test as much as straight up knowledge test. But anyways, let's get going here. So number 1, here's the key thing. You should have noticed on this histogram that I have 2 humps. We call this bimodal. Bimodal. We also could refer to these as 2 separate clusters. And notice here, the cluster is centered around 125. And over here, looks like around 260-ish. So therefore, we definitely know it's not uniform. So one test-taking strategy we ought to be very proficient with is eliminating bad answers. Uniform, right? Skewed to the left, definitely not. It's bimodal. Skewed to the left would be this, right? Skewed to the right, no. Skewed to the right would be this. The distribution has 2 clusters. So we're down this D or E. One of them is distractor. The other one's correct one. If you look carefully, E is the correct answer, centered at 125 and 260. You can go, of course, verify the range, but when you compare it to D, I don't think you need to even bother. But the range is basically simply this. So this is something else they may question you on, so we ought to do this. Notice the minimum value is 75. The max is 325. So range is by definition the max minus the min, highest minus the lowest, and that gives you 250. 325 minus 75. So number 1, know the ins and outs as I discussed it. Number 2, now this one's more straight up like we learned in class, like we practiced in Khan Academy and so on. Notice our sample size was 1,045. We know our p hat looks like is around 60.60. The hypothesis is to determine whether there's evidence of more than 50. So note that our H naught is going to be P is equal to 50%. So we're going to assume it's only 50%. But our alternative is going to be, nah, we are suspecting it's greater than 0.50. The key thing is 50% is our assumed proportion. Our sample gave us 60%, but the real assumption is, nah, it's really only 50%, right? So when you come to it, remember, it's just like doing a z-score, very similar to a z-score. We take what we got, we minus it from what we assumed. Again, it was 0.50. We divide by standard deviation. Now for a proportion, it's always P1 minus P over N. And remember with proportions, as long as the sample size and expected values are large enough, it's always normal. But always normal with proportions. But anyways, that right there, or actually, see how I almost got tricked? It's 0.4 and 0.60? No. So any 0.4 or 60s we're going to eliminate, because remember, we have to focus and understand we're assuming 50%. So therefore, it's either A or C. And if you look carefully enough, one of them has, see how this is backwards. Remember, you always want to take what you want minus what you assume to compare them, right? Direct comparison with subtraction. So by default, it's got to be C, but as you can see, there is my correct setup. The square root of P 1 minus 0.50 is 0.50 over our sample size, right? Square root of. Okay. Number 3. Guys, whenever they give you a graph like this box plot, take the time to label it. So notice our scale here is going by 2. So you can see right here, my Q1, as we say, the left edge is at 76. Notice the median is approximately, it looks like it may be in the middle, at 77. Notice the right edge here is at 80, so Q3 is 80. Notice the highest value is 94. That is our max, as we say, 94. And our minimum is at 72. This is called the 5-number summary, right? And remember, the range, by definition, is always the maximum minus the minimum. So notice our range is 22. The IQR is always, by definition, Q3 minus Q1. So if I subtract these, notice my IQR is simply 4. Now, I recommend you quickly do this. How long did that take me? 30 seconds maybe. Of course, it took me a little bit longer only because I was teaching it. But you guys got to know your 5-number summary. You got to know how to find the range in IQR, especially given a box plot. Okay, so long story short, we need to find which of the following must be true. Okay, well, if I'm looking at my choices, interquartile range being 22 is wrong. That's the range, not interquartile range. The range is greater than 90. Nope. So I already know A and B are bad. See how I'm eliminating answers. This is how you approach it, guys. The number of days of at least 80 on-time arrival is greater than the number of days at most 76. So at least 80 means this right here. That's my top 25%. At most 76, that would be my bottom 25%, right? So that's definitely can't be a possibility, right? The number of days from 76 to 80, 76 to 80, guys, follow the purple here, is my interquartile range, which is going to be 50% of my data. Could that equal the number of days at most 76? Can 50% be equal to 25%? I don't think so. So it looks like by default, guys, it's got to be E. The difference between the median and lower quartile, that would be right here. The difference is about 1. For a number is less than 2. Yes. So without a doubt, guys, there's a few tricky answer there is notice, but E is definitely the correct answer. Okay. So by the way, just without talking too much further, notice how I'm eliminating answers, right? And if you have to guess, guys, remember, you're going to answer every one of these. Even if you have to guess, at least eliminate 2 or 3 bad answers, and then you're down to a 50-50 shot. Remember, there's no penalty for getting it wrong. So you might as well guess and hope you get it right. Okay? Anyways, let's look at number 4. Okay, so this one we talked about in class. This one's straight up calculator. You'll be allowed to use a calculator. You're going to go to second vars. Second vars on your calculator is going to allow you to do normal CDF. Remember, we never do PDF, right? And you're just going to put in the information. Notice I would recommend always doing the sketch. We want to go from 114 to 138. We know our mean is 122, standard deviation 8, right? We put all that information in, and here is our answer. We know that 82% should fall between those two values of 114 and 138. By the way, guys, remember with any symmetric or normal curve, most of the data is going to be near the center, right? The mean, right? I mean, that's how it's designed. So be aware of that. Okay. So again, second vars. There's the vars button underneath our arrow buttons, right? So you're going to do second vars to get where you need to go. All right, last one. We're talking about water quality. Now, guys, notice they took measurements in a very wise way. Again, imagine here's the water surface. Here's the bottom of the stream or river. If we were going to measure chemicals, we'd want to measure, in this case, 9 times on top, 9 times in the middle, 9 times near the bottom. The idea is we collected data, right? But we didn't have any sort of like comparison or what we call control group involved. This was just straight up going, taking measurements, looking at the data, analyzing. Guys, that's called an observational study. So it wasn't an experiment. Again, hopefully you've seen through our problems enough of different kind of experiments that we've analyzed, right? It's definitely not a census. A census would be taking all the water, guys. Literally all the water and measuring every, liter of water in this river. That, of course, would be numerically, or you could, if you use your imagination, that's basically impossible to do, right? But the bottom line is this is definitely not an experiment. Experiment would be like we'd have a couple groups. We'd randomly pick each participants or subjects to go in each group. And then at the end, we compare them, right? We give them a drug or something like that. That's what an experiment does, right? You have that control. You're giving some kind of treatment. In this case, there's no treatment, no really control, as we say. We just went there, we measured the water very wisely at different levels, and now we're going to take those measurements, and we could compare them, of course, but we're going to analyze the amount of chemical in the water. That's what we call an observational study. And we're going to devote a whole unit to it in January. All right? But that's it, guys. I hope you watch and study this video, and I'll see you around.